Ever wondered how big data is processed? The answer lies in a framework known as Hadoop. Now, big data is not just a buzzword, it's a phenomenon that's changing the world. We're talking about data sets so vast and complex that traditional data processing tools just can't handle them. That's where Hadoop steps in. Hadoop is a powerful open-source framework that allows for the distributed processing of large data sets across clusters of computers. It's designed to scale up from a single server to thousands of machines, each providing local computation and storage. One of the core components of Hadoop is the MapReduce algorithm. It's like the beating heart of Hadoop, pumping data in and out, ensuring it's processed efficiently and accurately. So you see, Hadoop and big data are like two sides of the same coin. And to understand how we process big data using Hadoop, we need to delve into the creation of a MapReduce application. MapReduce is a programming model designed to process large volumes of data in parallel by dividing the work into a set of independent tasks. Imagine having to sort a library full of books. The map function is like assigning each person a section of the library to sort. Each person works independently, sorting their own section. This is the map part of MapReduce, breaking down a large task into smaller, manageable tasks. Next, we have the reduce function. Once everyone has sorted their sections, we need to bring it all together. The reduce function is like gathering all the sorted sections and merging them into one fully sorted library. In the context of Hadoop, MapReduce allows for efficient data processing. The map tasks are distributed across different nodes in a Hadoop cluster, and the reduce function then consolidates the results, making sense of the big data. Now that you've got a basic understanding of MapReduce, it's time to see how to develop a MapReduce application in Hadoop. Developing a MapReduce application begins with writing the map and reduce functions. Let's start with the map function. This function is responsible for taking raw input data and transforming it into a set of data pairs. Think of it as a librarian categorizing books according to their genre. Each book represents an input data, and the genre is the key. The process results in key value pairs, which are then passed to the next stage. Now let's move on to the reduce function. This function takes the output from the map function as an input. It's like the librarian, now armed with categorized books, deciding to further sort them by author. The reduce function combines these data pairs into a smaller set of tuples, further refining our data. In essence, the map function is your data categorizer, while the reduce function is your data consolidator. With the map and reduce functions written, we're halfway through developing our MapReduce application. After writing the map and reduce functions, the next steps are compiling and executing the application. To compile your map reduce application, you use the Java compiler, or Java. This creates class files for each of your Java classes. Next, you'll package these class files into a Java archive, or jar file. This is the executable file that Hadoop will run. Now it's time to run your application on Hadoop. You'll use the Hadoop jar command, followed by the name of your jar file and the input and output directories in HDFS. After execution, Hadoop writes the output of your application to the specified output directory. Interpreting the output, you'll notice that the map function's output becomes the reduce function's input. Each key value pair in the output corresponds to a unique key and its associated value from the reduce function. Congratulations! You've just developed and run a MapReduce application on Hadoop. Let's recap what we've learned about processing big data with Hadoop and MapReduce. We started our journey with an exploration of big data, understanding its enormity and complexity. It's like a vast ocean filled with valuable insights, just waiting to be discovered. Then, we dove into the world of Hadoop, a powerful tool designed to navigate this ocean. Hadoop, with its distributed storage and processing capabilities, makes it feasible to swim in such deep waters. Next, we dissected the MapReduce process, the mapping phase where we break down the problem into smaller parts, and the reducing phase where we aggregate the results to form a coherent answer. Like a skilled craftsman, we took apart and then reassembled this intricate mechanism. We also walked you through the steps of developing a MapReduce application in Hadoop, guiding you on this complex yet rewarding journey. With the knowledge of MapReduce and Hadoop, you're now equipped to tackle the challenges of big data processing. Until next time, keep learning and exploring.